words and phrases and definitions, please don't fret. We're going to use those words again and again. In fact, this whole lesson, I think, could have been part of yesterday's homework. Not all of it, most of it. Okay? I'm just going to use the same words again. It's almost like pause, hold on. Let's just go over all this again and make sure we get these words down pat. Okay? So, properties of quadratic functions. Instead of being called graphs of quadratic, it's just properties of quadratic functions is the name on here. And the learning goal is describe key features of the graph of quadratic relationships and use the graphs to solve problems. Lots of questions coming. Where do the graphs come from? How do we build the graphs? Yeah, oh yeah, we got a whole month to work our way through all those details. For now, graph is given. There it is. There's a quadratic, they tell us. What are these things? Vertex. Okay, write these things down. Vertex. And I'm going to try and write today as little as I can. Not because I'm lazy, but because I want you to just have the phrases you need to remind you what these things are. The vertex is the highest or lowest point. I think I defined it differently yesterday. I think I called it where the axis symmetry meets the graph. I think that's overcomplicated. That's technically true, and that was the technical definition. But really, what do you want to know? It's the highest or lowest point. So here, can you see it there, vertex? 1, -4. Yeah, good so far? Zeros, new phrase. I don't think we really called them zeros before. But the zeros are the x-intercepts. And I'm going to do something that might catch you off guard at first. I'm going to put the s in brackets. We're going to find out later in this lesson that parabolas can have one x-intercept, two x-intercepts, or no x-intercepts. Okay? But I'm just mentioning that, and that's why that funny s is there to go, I don't know if you need an s here or not, because you might have two, you might not. What are they here? There's two x-intercepts here in this one. Let me put them on there. 3, 0, -1, 0. If you're ahead of me on all this, you're thinking, yeah, but how am I supposed to know what they are if I don't have the graph? I'm like, I know, today, we've got the graph. So yes, I'll teach you all that, but for now, we just look at the graph and see where they meet the x-axis. Yeah. Axis of symmetry. I like this phrase. The center line. All parabolas have a center line. They have an axis of symmetry right down the middle that divides this thing in half, and they're symmetrical about that. Here comes the axis of symmetry. Beep, 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 beep. We usually do it as a dotted line because technically it's an imaginary line. Like it's not really on the graph. We're just using that line to go there. There's what breaks it in half. But the axis of symmetry, the equation of the axis of symmetry, very difficult. We saw one yesterday. I'm going to come at it again today. I'm going to pause. Awkward pause to get someone to answer the equation of the axis of symmetry. It's a problem because I've been beating you up with y = mx plus b for weeks now, and then this thing comes along that's a little bit different. Chris's hand's been up for an hour. X = 1. It's so ridiculously easy to do the equations of axis of symmetry. It makes it hard because it's so easy. It's all the points where x = 1, right up here. X = 1. So it's an x equals equation. We did it. We talked about special cases, but we didn't talk about them for long enough. We really didn't. We did so much y = mx plus b. There was so much work to do that we forgot about the two special lines. The vertical lines, which were x equals, and the horizontal lines, which were like y = 4 or y = 2. Okay? But hopefully after seeing it twice, you're like, okay, maybe I'm starting to get the feel for axis symmetry. Optimum value. Okay, if you've slept through this and some of the look on some of your faces, you have slept through part of this lesson. You want to wake up for this. Important little detail here. The optimal value is the smallest or largest, I'm going to change colors here, y value. All parabolas will have a high point or a low point. One of the two. They won't have both. They'll have one of the two. And this one has a high or low y value. It's got a low y value of -4. Really important that you write y equals -4. There's a reason for that. Once we get into doing some real-world parabolas, these parabolas will represent something we're talking about. Maybe this is Mr. Todd's bank account. This is close to what happens in my bank account sometimes. All the way down to -4. See, the y value is what's important about that. Chris?
The only difference with vertex is we don't include the x value.
Yeah, the vertex has both the x and y. The vertex is a point. The optimal value is just the y value of that point. And that's the kind of detail that might worry you a little bit, like, okay, I got to get used to these two different things that sound sort of the same. Yeah, that's why we're doing it 2 lessons in a row. If you're out there sort of bored going, this is mostly yesterday's stuff again. Yeah, I know, because these words, we gotta flesh them out a little bit. Y-intercept, okay, well that one, maybe you didn't need me for that one. Y-intercept, oh, I'm gonna go back to the red there. I want the blue to stick out. Y-intercept right there. I don't have anything to say about the y-intercept. I hope the y-intercept is like, yeah, we did y-intercepts before. It's where it meets the y-axis, and parabolas meet the y-axis once. You just got to find it on the graph. How are we going to find it? Oh, well, we did learn about that yesterday. We can do it without the graph. And I'll talk about that before the lesson's out. It was the last number. The last number was the y-intercept. But more on that coming. We don't have to have that perfectly yet. Any questions on that page? It's okay? All right, we carry on. You let me know when you have questions. And go back questions too. If I say something in these lessons that you're like, oh, now that confuses me. I thought you said it was this, and we have to go back. Yeah, let's do that. They're not terribly long lessons. So we have lots of time to go back with questions. Examine the, oh, well, let's not wait around. Let's see if we got that down pat. You try. Take a couple of minutes and go through these 5 questions and see if you can, from the graph that's given there, can you answer these 5 questions? I'll put the answers up in just a minute. We'll take them up together. I'll set a timer. How long do you need? You need 3 minutes. Set a 3-minute timer. Do you even need 3 minutes? Maybe you do. Video people, you can fast forward 3 minutes. We're not doing anything for 3 minutes. Discuss as needed, compare as needed. Maybe you're already done because you're so smart.
She hands me those and this. See that? We gotta shut this front door. I don't know, these ones don't really taste like it. The other ones are really strong. Sugar free. 3 calories. It's white. There's no color. It's probably there's probably a white sauce. Oh. No, it's artificial. Natural loose number. Chocolate. What? It's loose number. Oh. Yeah, 40. There's a bunch of whites. No, there's other stuff. There's other whites. Yeah, most of the stuff just comes to white because. Yeah. It'll make you throw up, but.
Sticking to my 3-minute promise, even though I hear you talking. I'm not criticizing. I'm just saying. I take that as good news. That you're like, we got it. We got it.
Mints might get old then. These are from 1999. Oh yeah.
Okay, 3 minutes. Who's got it? State the y-intercept. Is that the easiest question on the page?
What other flavors?
Say it again. Y equals -3. Do you have to write y equals? I'm going to say yes. And not because I would be willing to lose an argument here. Say, you said y-intercept. Can I just write the number -3? Yeah. But there's so many times where we have to be specific about which we're doing, x or y. Let's get in the habit of every time it comes up, let's say what we're talking about, x or y. It's just a good habit to be in. What are the zeros? Right, so 1, 0, and 3, 0. You could also write it like this. You could say x equals 1 or x equals 3. To be honest, that's how we will start writing it because of the nature of something we're going to learn later, but either way is fine. I'm not trying to switch you over. I'm trying to mention that as we go along, we'll probably write it this way. We'll probably just write the x values. That's okay. Coordinates of the vertex. This one you have to get right as far as how you write it. This has to be right. 2, 1. Yeah, in the little brackets to say it's a point. 2, 1. There it is, the vertex. And the equation of the axis of symmetry. This is the one I'm worried about. X equals 2. And again, I don't say that that's particularly hard, but it's our fault. We didn't do enough of it. We did all y equals mx plus b. We kept doing that, and we didn't do the special lines enough. But it sort of makes sense, right? It's where x equals 2. Yeah? It's the only sensible line equation that I know of, where you go, yeah, x equals 2. Yeah. And then the optimal value, y equals 1. Okay, so get used to writing y equals 1. That's the only one I'm really picky about. If you just wrote 1, not good enough. Y equals 1. And is it a max or a min? It's a max. You are happy? Yes? You're happy? What's that? Oh, with he says, with this or with life? With this, I'm happy. Life? Still a little dreary, the weather, eh? Not quite. It's like spring eve, but not quite spring yet. It's coming. It's coming. I looked at the weather. It was next Friday is the last of the single-digit days. We start getting double-digit highs every day. I think that everyone spruces up after that. Yeah, all right. So a little more details. Again, I don't think this is surprising, but this is just me typing on the note going, just make sure they know at this point in the note, maximum and minimums. For quadratic relations, the y-coordinate of the vertex is the optimal value. That's what Chris said. He said, okay, the vertex is an x and a y. The optimal value is just the y. And the y-coordinate can either be a maximum or minimum depending on the direction of opening. We've seen one open upwards where it was a minimum, one open downwards where it was a maximum. Okay. On we go. Some more details about that. Again, I don't know if this slide, I made it fill in the blanks because I didn't want you to have to write this all out because it might be like, yeah, duh, I got it. I understand. You're beating it up now. The vertex represents, for an opening up parabola, the vertex represents the minimum point of the parabola. And the y-coordinate of the vertex represents the optimal. And by optimal, we mean extreme. It's either the highest or the lowest. Hey, why do we say optimal? Some situations we're looking for the highest, and sometimes we're looking for the lowest. If this was a graph of my expenses for the month, I'd want a low value. If this was a graph of my profit in my company, I'd want a high value. That's why I say optimal. Max or min might be good or bad depending on what you're talking about. So let's not get too excited that max is good, min is bad. It depends on what we're talking about. And it's going to be a while before we put these into real world situations. And the second difference of the parabola, I just threw that in there like, and don't forget from yesterday, the second differences of the parabola will be equal. That's what we found out yesterday. That's how we really tell if something's a quadratic. Well, then this one is just all the opposite ones. If the parabola opens down, the vertex represents the maximum. And the y-coordinate is still the optimal value. Even though, at first glance, you might think, well, I want the highest. Not if it represents costs, you don't. You know, like it depends on what we're talking about. And the second difference is, I just threw that in there on this page again to make sure that's very clear. The second differences will be equal. This pen's wonky. Some of you found out when you're up here. If I try and write on the side here, it goes all into Halloween writing there. You know, I got to remember to go over here to write. So, I like how it looks though. It's like a fun font. Is that all okay? It's like, yeah, thank you. I had that. But thank you for putting it on a separate slide for me. And then more on zeros of parabola. The x-intercepts of the graph are the zeros of the parabola. And if you've drifted off to sleep and lost attention, I understand. But you might want to come back for this, because this is where we're going with this. I haven't talked too much about this. The x-intercepts of the graph are the solutions of the equation. That should both get your attention and scare you a little bit, like solutions of the equation. We didn't do solutions of the equation yet. We didn't solve these equations. How are you going to solve with the square root? And your brain starts to freak out. I'm like, I know, we got a whole month. We'll get to all that. But that's where we're going with this. We're going to have to solve the equation with x squareds. And zeros are the x values when y equals 0. And that might be, well, duh. But that's what we do to find the x-intercepts, is we set y equal to 0. Oh, I can't resist. Given a parabola, what we're going to do is we're going to set this equal to 0, and now we got to have a long conversation about how to solve that disaster. We cannot do it at this point. So don't sit there and go, oh, I can just isolate x. Isolate x is not going to work. We need something more here, so I'll put some big question marks there so you know where this is going. This is like, what are we going to do next? Well, that's what we're going to do next. Not today, but we're going to have to deal with these equations at some point. At some point, not yet. More time there? Slide 5 of 9 for me. Hopefully nothing mind-blowing so far. A couple little details to add on to yesterday's. Here's what I was talking about earlier. Parabolas can work out 3 different ways. Parabolas could have 2 zeros. This happens if it's opening upwards and the vertex is below the x-axis, but it can also happen this way. If it's opening downwards and the vertex is above the x-axis. You don't have to have all this memorized yet. All you need for today is, oh, this can work out 3 different ways. Maybe the parabola just hits the x-axis. The vertex is on the x-axis. When that happens, whether it's opening upwards or downwards, you get 1 0. But we can also get no zeros. So when solving these equations, we might find there's no answers. That's new. That's new and weird. And so if the parabola is above, the vertex is above the x-axis and you're opening upwards, you don't get any zeros. Or if the vertex is below the x-axis and opening downwards, you're not going to get any zeros. Haven't solved that yet. Haven't really dealt with it. I'm just noticing that there's going to be different cases here that we're going to have to deal with. It's not going to be as hard as it seems. It seems like, well, how am I going to know? You don't actually have to know. You just have to be aware it could happen. And when the algebra tells you it's happened, you shouldn't be surprised. What algebra? Yeah, got a whole month. Don't panic. Don't panic about this. Just be like, 0, 1, or 2. Wonder what's going to happen. Interesting. Questions? All right, some spicy examples. After all that, that was like not really a review of yesterday, just like re-clarifying yesterday's stuff. Here's some spicy examples. Create a table of values for y equals x squared minus 4x minus 5 and sketch its graph. Some people were asking me about, well, what does this number do? What does this number do? And the answer is, I don't have an answer for you yet. But we can begin investigating what all this stuff might mean. So I promise this is not the way we're going to do them long term. So if this seems long and crazy, that's on purpose. We're going to do the long and crazy version so that when we do the short version, you'll respect it. You will love it when it happens. But for today, all we're going to do is to find out what the graph for x squared minus 4x minus 5 looks like. We're just going to sub in numbers. So I'm going to sub in -2. So it's -2 squared minus 4 times negative 2 minus 5. And we're going to rely on our calculator. So get your calculator out and make sure you're good at typing these in. Because if we're going to rely on our calculator, we better know what we're doing with ours. So get yours out and type that in and see if you get the same answer as me. And you can move ahead of me too. I'm just going to go through them now and just type these all in. Negative 2 squared. Oops. Delete. Delete. Squared. Minus 4 bracket negative 2 minus 5 equals, I get 7. Did anyone else get 7? Now, if you're completely annoyed right at this moment, hold on. Hold on. I've got something for you. I've got a gift for you if you've got a decent calculator. Let me show you that subbing on my on-screen calculator, and I'll show you a shortcut. A shortcut coming up. Maybe for the first time in the whole lesson, you're sort of waking up going, what shortcut? Tell me, shortcut. I love shortcuts. I don't know if your calculator looks exactly like this. This one I'm going to bring in the screen, but it'll be similar enough. There it is. Hello, Mr. Calculator. Oh, I brought 2 of them up. I don't need 2. I'm worried about the memory on my computer. Remember yesterday when I booted down? That was scary. Watch, friends. If you type this in, you go bracket negative 2 squared minus 4 times negative 2. I already pressed the wrong button. Negative 2 squared minus 4 times negative 2 minus 5. You type that all in and you get 7. And then the next one says, do it again with negative 1. You're like, I don't want to type it all in. Watch this. Arrow back on your calculator. Just press arrow back, and you can arrow back. Mine, I use backspace over the 2 and change it to a 1. Go over here and backspace over that 2 and make it 1. Maybe yours does, you need to use delete. Maybe on yours, when you press 1 over top of 2, it just takes its place. That's part of getting to know your calculator, okay? So you type that all in, and I get 0. I give you permission when building these tables to use your calculator. That you got to show me on the first one, you know how to write it, and then the other ones you can just write in the answer. 0. Well, that's interesting, but we'll get to that when we graph it. Okay. Now do it with sub in 0. So I go back and I change all my negative ones, and backspace over that, and change that to 0. Backspace over that. Change it to 0, and I get negative 5. Are you surprised it was negative 5? I don't think you should be surprised it was negative 5 from something from yesterday, but we can talk about that in a second. Then 1. I'm trying to make this as not torturous as possible by letting you use the technology you have to just type these in and get these answers. Negative 8. And then change that to a 2. Negative 9. Interesting. Interesting. And I'm going to put in 3. I hope you're doing it too so that you know you can handle this. You can easily type these in. This doesn't take as long. You're probably faster than me. I got to press these awkward buttons on the screen. You can probably zip through this pretty fast. Negative 8. Now, I don't know. Is there somebody who's getting the feel for parabolas? Who already knows now what the next value should be? Negative 5. We've now found the vertex. Is this the best way to find the vertex? No. I've got other tricks coming. But you could do this. You could just sub in numbers and get them all in there. So if you sub these in, and I'm going to finish it off for the sake of the video, and for you to see it once, that it actually does work. I'm not just making up stuff. I get negative 5. I'm not surprised by that. Because parabolas are symmetrical. They do the same thing on either side. And I think I found out lots of stuff. I hope you're like, oh, we know everything there is to know about this parabola now. Is subbing, again, I'll say it again, is subbing the best way to do this? No. We'll find out we're going to have other ways. But subbing works. Better get the right, 0 again, and then I better get 7 again on the last one. Seven. Now graph all those points to see the parabola. So -2, 7. Got it? -1, 0. 0, -5. 1, -8. 2, -9. 3, -8. 4, -5. 5, 0. And 6, 7. Beautiful. Got the whole parabola. Now, how am I going to do here? Through the points. Through the points. And like last chapter, this parabola goes on after that, but it goes off my page. So I just put arrows there to let everybody know that goes off the page. And we really should label it like we did last chapter. Now we do all this stuff again. Equation of the axis of symmetry. Who's got this now? X equals 2. Good. For axis of symmetry, you just do the x equals. For the vertex, we do the point, 2, -9, right? Y-intercept, do you see it?
-5.
Yeah, and I'm going to write y equals -5, where in the case of y-intercept, I guess technically you could just write -5, but let's get in the habit of always writing x or y so we don't make a mistake in a question where it's important to write y equals. Notice that's the only thing maybe somebody could have predicted before this started. There. Just like last chapter, that number by itself is the y-intercept. It's called the C here instead of the B, but don't let that mess you up. It just means the last number. Yeah, the last number will be the y-intercept like before. Zeros, no way we could have predicted what the zeros were going to be. X equals -1, and I'll add one more move you can do here. You can write it like that. If that messed you up, write like this. But we'll do it with a comma coming up. So I just mentioned that. You could write it with a x equals -1, comma. It's not a point. I didn't put brackets around it. I just was listing them. But if that's messy for you, then write the one underneath. And the max or min value, y equals -9. Is it okay?
Wait, why is it 3?
What's that?
Why is it 3 on zeros?
Why is it 3? I didn't write.
Why is there 3?
There's not. I said you could write it this way,
Yeah.
or you could write it this way. That's the way I had been writing it, but I'm mentioning this one because as we move forward, we'll probably write it that way. It's a minimum. Oh, did I say maximum? I just misspoke. It's a minimum. Yeah. Is that what you were wondering about too? Right there. Is it good? Is it okay? Good. Okay. Do you have questions? If you don't have a question, I'm going to ask a question for you because there's a question you should be asking about this whole situation. The question should be, are we going to have to build a table of values every time to get all this information? And the answer is no. This is just us getting to know parabolas a little bit. And I'm going to use a table of values to get to know them a little bit. We'll get much, much better methods as we go along. Okay, so like every day, I'll increase your quadratic powers, and you'll get better and better at doing these things without long table of values. Having said that, if you were stuck now and you needed a hint or you needed something going on, you've always got the table of values to fall back on to go, what the heck is going on here? Yeah? Okay, so I don't want to belittle this, how powerful this is. It's long. It takes a long time. It's boring, but it gets the answers, baby. You know, and so the methods I'm going to show later can be a little more difficult to do, but go faster. That's always the deal in math. We find a new way that's faster, but it's a little harder to understand. Most people understand this pretty well. We could have done this the first day I was in here and just built a table of values. That's not particularly difficult. That's page 7 or 9. We're almost done. Well, no, it's The last page is just the homework. So actually, you only got this page to go. So if you're running out of attention span on what day of the week is this? Wednesday. But why is my brain saying it's more like a Thursday? Why is that happening? Oh, Good Friday. So really, it's more like a Thursday, isn't it? Question. I don't have your test marks. Things have spiraled out of control. Not in a bad way. Nothing going wrong in my life. Just really busy. But, so 50-50 chance I'll get it done tonight. It will definitely get done over the Easter weekend. So right after you have your Easter dinner, you could email me and say, hey, where's that mark? And I'll give it to you, okay? All right. This time, no table of values. I just put the two graphs up. Y equals x squared minus 12x plus 32. There's the graph for some reason. And then this one is the second one. Okay? So I gave you the graphs. It's back to, let's get the information off the graph again. Let's do the first one together, and then you can try the second one on your own. Coordinates of the vertex for the first one. 6, -4. Equation of the axis of symmetry. I hesitate because it's one I'm worried about, but maybe it's become easy. Went from hard to easy during today. What's the equation of the axis of symmetry? X equals 6. Thank you. Step pattern. Oh, what? I can't really see on here what the step pattern is. Let's see, over 1. Oh, the scale's 2 here. Oh, that's annoying. That is annoying. So let's see, over 1, up 1. Then it goes up 3. Then it goes up 5. Okay, I see it, 1, 3, 5. But I don't say that's easy when the scale goes wonky like that. That takes a lot of staring at it going, what is going on here? I encourage you not to do this to your scale. Go up by ones if you can. Why do people do this then? Well, sometimes the numbers become too big. Did you run into this in science yet? Where you had to go up by 2s or by 5s or something because the numbers got so big. Anyways, this one is a 1, 3, 5. Direction of opening. When you're doing your dance and you're doing this parabola, what that means is, where are your hands? Are they up or down? And this one's up. Yeah? Y-intercept. Oh, I can't really see it on the graph. I'm lying. I can see it. Do I need to see it now? I can pick it off here now, can't I? It's the one powerful thing we've got so far is y-intercept. We can pick it right off the equation. It's on the graph there. I was lying. You can sort of see it in the graph there, 32. Zeros. X equals 4 or x equals 8. I'll put them right in the graph. Maximum or minimum? Is it a max or a min? Minimum. And the optimal value is y equals -4. By optimal, we mean like if this was a graph of my, my expenses, my company, the lowest is -4. I know it does make sense my expenses is -4, but I'm just making the point that sometimes you want the lowest. Lowest is good sometimes. All right, take 2 minutes and try this one, but the step pattern will be very, very difficult with this graph. If you have to skip over step pattern, just leave it blank and I'll talk about that in, well, you seemed like 3 minutes was way too long. 2 minutes. Set a 2-minute timer and see how many of those you can do. I think you should be able to do all of those. It's going down for real. For real. How do I write that on Facebook? Do I write FR when I'm saying things on Facebook? For real. When I want to say for real. You can? That's a thing? Except that I'm using Facebook. That's the only problem with that whole statement, right? Hey, we're going to be done by 11 o'clock. Aren't you excited? And what did you say about the homework yesterday? The homework was?
Very digestible.
Very digestible, he called the homework yesterday. It's a great phrase. Yeah? Did you mean digestible because it wasn't that long or because it was easy or both?
It was a good amount.
It was a good amount. Well, hopefully today's is a good amount. I hope that homework is digestible for you today as well.
It was not too much.
I'm just noticing what the grade 12s wrote on the board back there. A picture of the Titanic. This is how they're feeling right now in grade 12 with their upcoming test.
Are they gonna cheat?
Is my timer working? Yeah, 45 seconds still to go on my timer. Skip over step pattern if you have to, or if you got time, work on it because it's a little weird. The step pattern's a little weird. Yeah, it's hard, but I heard someone say something about the step pattern. Maybe somebody's on the case. It's very weird, though. It's very weird. Okay, corners of the vertex. Is that easy now? It's like bang, right there, 4, 8. I almost said 4, 6 because the picture is so small, it looked like a 6 up there. But then when I looked at the scale carefully, I went, oh, it's 2, 4, 6, 8. Maybe you wrote 6 as well. On my screen, even as big as my picture is, that really looked like a 6 when I first looked at it. Equation of the axis of symmetry. Is that easy now? Yeah. Did you do the Donkey Kong voice? Yeah. Do you know who Donkey Kong is? Yeah. Okay, x equals 4. We'll skip step pattern. We'll come back to it. Okay? We'll agree that that's sort of difficult. Direction of opening. This is where your hands are if you're doing the stance. Down. Y-intercept. Is it y equals negative 24? That's the one thing we can get from two places right now. We can get off the graph. You can see it right there in the equation if you need to. Zeros, 2 and 6. Did you get 2 and 6? That's 6. That's actually 6. Is it a max or a min? Maximum and optimal value y equals 8. Is that part okay? Okay, some extra spice here. In the spicy question, spicy stuff here in the step pattern. Did anyone find the step pattern and feel confident about it? Couldn't tell. Did your hand go up or no? Yes, sir. 2, 6, 10. She says it goes down 2, then it goes down 6, then it goes down 10. That's the steps this time. And I say it's negative 2, negative 6, negative 10. Okay? So if you've drifted off to sleep and you're like, oh, this is so easy, this is my only really big moment in the lesson. Mr. Todd, you're a big fat liar. You said it was going to be a 1, 3, 5 pattern. I'm like, I know, this one is too. What happened to the 1, 3, 5 pattern? It's been doubled and switched to negative. Do you agree? Look here, friends. That number out front tells you what step pattern to use. So, this step pattern was negative 2, negative 6, negative 10. How are we going to get it long term? I'm going to adjust it. I'm going to say, actually, the step pattern, here's the step pattern. My only big moment in the lesson is actually 1A, 3A, 5A. It is a 1, 3, 5 pattern, but you multiply it by whatever A value you have out front. That'll tell you the step pattern. Extra detail. Hopefully you're only one of maybe only 2 big details in this whole lesson. I know that looks weird when I wrote it, but all I mean there is you take 1, 3, 5 and you multiply each one by the negative 2 that's out front. And that's how you get the new step pattern. And if that's weird, that's okay. It's brand new. And hopefully your only real brand new thing in the whole darn lesson.
Will parabolas always be in that step pattern?
Parabolas always follow. Now I'm not lying. Now I'm telling the truth. Parabolas will always follow the 1A, 3A, 5A. Whatever that A is out front, you multiply that by the 1, 3, 5 pattern. So the way I said it yesterday, the second time I said it wasn't a lie when I said they follow a 1, 3, 5 pattern. Some multiple of the 1, 3, 5 pattern they're going to run every time. What multiple? That number up front. That's the number. So going to get a lot of details. We've got to juggle here. We're going to be cat in the hat by the time we're done. We're going to have y-intercepts and x-intercepts, optimal values, 1a, 3a, 5a. There's going to be a lot of stuff going on here by the time we're done. Yeah, it's good math. Makes your head hurt. Yeah, like a good workout. You know it's good when it hurts. No, he says. No, thank you. Here's some very digestible homework for you. Notice, though, it says number 8, do it on Desmos. So when you get to number 8, feel free to get out your technology, break out your Desmos on your phone, and do number 8 right on your phone, okay? Your time is your own. Use it wisely.